for Jerome.
All right. I hope I'm clearly audible till the end. Good morning, everyone. Thank you for joining this particular session. It's good to see you all in this particular role. And it's my first time in Australia. It's been pretty amazing. To start with the context, in this particular session, what we will do is, we'll talk about what is MCP, what is the need of MCP, and what are the pain points using the large language models. And once we have some basic understanding, we will try to understand how MCP works, what are the different architecture, and how the transport mechanism works, and also the security part. And just to make this session fun as well, I have some of the code demo that I have developed where you can connect any MCP with an agent, with any agentic frameworks, and then we have a quick demo using Streamlit. Sounds good, right? Is it audible? Cool. All right, so here is a quick intro of myself. And apart from that, I'm part of Google Developer Expert Program, where I typically talk about anything related to agents, large language models, and around it. And I've been part of Google Summer of Code for 2 consecutive years, so I'm pretty much into open source. I've been part of Red and Lab in 2024. And in 2023, I was part of C Microscope. And in my free time, I watch anime, One Piece being my favorite. If you don't hate One Piece, probably we can have discussion later. All right. So how many of you have heard of context engineering? OK, a few of you. How many of you have heard of prompt engineering? All of you, right? So there is a thin line difference between what is context engineering and what is prompt engineering. So you might, again, have some kind of understanding, right? Hey, why do we have context engineering when you already have prompt engineering? So at the end of the day, you just have to get the prompt, you have to give it to the LLM. So that's the prompt engineering. And even if you have context, you can just feed it to prompt and then give it to the LLM. What does it make any difference, right? So there is a difference when it comes to context engineering and as well as prompt engineering. And these are some of the amazing tweets that I just collected about context engineering. And one of them is the co-founder of Shopify. He just said, hey, prompt engineering is good, but when it comes to LLMs and an agent, context engineering makes more sense, right? And then we have Andre Karpathy, who is a very well-known person when it comes to AI domain. And even he had the same thoughts when it comes to prompt engineering and as well as context engineering. So here is how context engineering works, right? Prompt is just a string template that you pass to the large language model. But what about context engineering? It is a system. So this system is like, how do you process or how do you develop a workflow that takes all the context from relevant sources and then you give it to the prompt? So this can be your RAG pipelines. How many of you have heard of RAG? Everyone, cool. So basically, you have your own data. You fetch the relevant information based on the user query from your knowledge source, whatever you have, and then you give it to the prompt, which is later passed to the large language model. And then we have memory, and apart from memory, we have prompt, and also apart from the prompt, we have something called as state management, which is typically used for memory, right? Now, here what I'm doing is, I'm adding one more component that is called MCP, right? So at the end of the day, MCP solves a major problem when it comes to large language models. So what are these problems that we are talking about? So let's take a moment and understand what large language models can do, right? So large language models can help you write good emails, but can it send automatic email once you think, OK, this is a good email, can you send it across? Will it take the action? Yes or no? No, right? So LLMs are good when it comes to static response generation. But if you want to perform any action or automate some stuff, it is not possible using just the base model that you have. So large language models are just the base models. What you need is you need to give the tools integration so that it can perform certain actions, right? And just like that, you have other description as well. You can create calendar description on how you need to send it to your clients, but you can't create the calendar invite directly. You can just create the description or design it, right? So these are some of the issues with large language models, and the list keeps going on. And here we have something called as model context protocol. MCP is nothing but you have certain context, which is passed to the model in a protocol way, which is the standardized rules. So now if you notice these 3 keywords, what you're supposed to do is, hey, let's suppose you have a model called Gemini or GPT or any other application. And now what you are trying to do is you have your own set of tools. So these tools can be your emails, it can be your calendars. based on my given requirement, you're supposed to pass certain protocols, and it is passing the context to the large language models. So it's a universal adapter, right? Universal adapter in the sense you have your LLM models, and then you're passing multiple integration. So this multiple integrations can be your Slack, or it can be a drive where you have your data. If not, it can be anything of your knowledge bases, which is nothing but your Quadrant or Airbnb. And apart from that, there are different tools that you can utilize. So these tools are nothing but your local file system and XYZ. So now, if you want to understand MCP as a whole, there are 3 components. So the first component is your host. Then you have MCP client. Then you have MCP servers. So MCP client is nothing but, how many of you use Cursor here? Claude, have you heard of Claude? Right, so Claude is one of the MCP client. So where user is interacting. So if I interact with Cursor, Cursor becomes my MCP client. Then you have MCP servers, which has multiple tools integration. These tools can be search, get the result, or it can be anything related to your databases. Right, so this is the need of MCP. Mainly, whenever we are trying to build any tools integration, most of the times you have just function calling. Now, there might be some question in all of you that, hey, we have function calling in LLMs. What makes an MCP different than a function calling? So when it comes to function calling, you have to write your own custom integration. If you need, let's suppose calendar as an example. So in calendars, what are the different examples you can do? One is you can schedule the event. One more is you can add the guest list. And third, you can also send the automated emails. So there are 3 different tools. There are 3 different integrations, right? So if you are using function tool, you need to add integration for all of them. But when it comes to MCP, you already have the integration available for every single tools within a single MCP server. And the second thing is, you need a standardized way. You need the standardized protocols on how the client and server needs to interact, right? There is a specific format to it. So I'll talk about that format in a short. So now that we understand the need of an MCP, which is a bit different than function calling, let's try to understand how MCP works and what are the different transport mechanisms that is used within an MCP to make your client and server interaction much efficient. All right, so this is a bit sequence diagram here. So as you can see, we already have 2 components. One is the MCP client, and then we have MCP server. Basically, a user will interact with MCP client, which is your Claude. So as you can see, you have different integrations. You have system prompt, you have user prompt, and then you have context. So as soon as I ask any question, client will send a request to the server. Now what server will do is, server will send the response back to the client. And here, there are different API integrations. Just a second. Is all good? Am I audible? Cool. So now that you see, you have MCP client. MCP client will send the request to the server. Based on that, it will send back to the response back to the MCP client. So here, the interaction is, you're not getting the response back. You're just sending your query. This query will tell which is the most relevant tools. So let me give you one example. I have an MCP server, and here my question is, what is the stock price of NVIDIA today, right? So here, the major keyword is stock price. And the tools I have is, I have Google, I have Yahoo Finance. Which tool do you think is most relevant? Yahoo Finance, why? Because Yahoo Finance will help you to get the results of what the stock price is. So you have a task. This task is the stock price. Now, when you ask this question to the server, the first response back will be, hey, what tool should I use? Should I use Yahoo Finance or should I use Google search with the parameters? These parameters are nothing but the searchable parameters. Once the client gets that requirement, again it will send that parameters to the LLM model, which will generate the final response. So this is how the interaction will happen between the client and server. Now, if we talk about a bit how this transport mechanism works. Now that we know MCP is able to interact with server, but how is it happening? What are the parameters passed, right? So the first basic principle that we need to understand here is, when you are trying to exchange the information between client and a server, it is happening via JSON RPC, which is basically a stateless remote procedure calls. So if I ask any question, what is the stock price of NVIDIA today? This is the example. What it will do is it will use the JSON RPC 2.0 format. You have the ID. Then here you have method. So what is the method here? It's just using tools or call, which is nothing but function calling. And here in params, the name will be Yahoo Finance, right? Now for Yahoo Finance, what are the supported parameters? It can be the company name, it can be the stock price, it can be the company description. There will be tons of parameters which a tools has. So you're also passing those tools as the argument. So this is the basic format of JSON RPC, which has ID, which is unique. Then you have method, and then you have params. So now client will send this input to the server. Now once server gets back, server will send the response back, which will have the final results. So this result will again use the same ID, and then you will have the results. So results will basically have two parameters. One is the LLM response, and one more is the success message, which is 200. And I have a Streamlit demo where I will show you the results on the UI part. All right. So now that we know how MCP client and MCP server talks to each other, we also see we have JSON RPC format. But how do we connect, right? How do we build our own MCP? How do we send any MCP server that you have developed to the end customer? So this is where there are two different formats. One is either you can send it the local packages, which is basically happening via STDIO. STDIO stands for standard input and output, which is basically running in your local CLIs. But if you want to deploy it and then send it to your customer, which is running remotely, this is where you have something called as SSE. OK, my Siri was on. OK, so the second thing is you have something called as SSE. SSE stands for servers and events, which was available till 2024. But in the recent days, the Anthropic team has converted this SSE into streamable HTTP. So streamable HTTP is where you have both HTTP and as well as SSE, so that we have some flexibility of using RESTful APIs, like post methods, get methods, and all. All right, so let's talk about how both of this transport mechanism works. At first, we have STDIO, which is basically standard input and output. The major use of STDIO happens if you are running any MCP servers locally, right? When I mention MCP servers, I'm not just talking about one tool. It can be 10 tools within one single MCP server. So first thing is, here, whenever you're trying to use STDIO, it will create a sub-process. So basically, when you have a task, you will divide that into subtasks. And then whenever there is any user query, you will send the request in std in. So std in is sent by the client. So now here, what you're supposed to do is, let's take the example of Yahoo Finance. So what is the JSON RPC look like? You have ID, you have method, you have params. So the basic principle here is, when you're sending std in, you should not send additional messages. So these additional messages are like, hey, I'm sending the input to the user. That is a message. We don't need any messages when you're using std in. So this is what stdio will keep in mind. Whenever you're sending any input, it will only take the JSON RPC format, and then it will give it to the server. The additional messages, whatever you pass, that will be removed if you're using stdio. And now, stdio is running locally. The second thing is, if you want to deploy it, and if you want the endpoint URL that has to be shared to the user, this is where you have streamable HTTP. So when it comes to stdio, you only have your root folder. You have your entire repository that you're sharing. But when it comes to streamable HTTP, you're not sending the code. Rather, what you're doing is you're deploying it, you're getting the endpoint. So this endpoint can be your custom URL /SSE. And now this URL is shared to the end users, and then you can access all the tools that you have developed within that particular MCP server. Now, there are two advantages over here. The first advantage is you have multiple inference that you can try. And the second advantage is you have streaming approach as well, which is applicable when you're using HTTP. So since we're using streamable HTTP, all the RESTful APIs that you have, which is your post method, get method, can be accessed via streamable HTTP. All right. Now coming to the major concept, most of you will be using the existing MCP servers itself, and we have MCP servers applicable in multiple industries, whether it is autonomous, whether it is travel, whether it is anything related to vector databases. you have a GitHub repository called Awesome MCP Servers, which has multiple MCP servers considering GitHub, Drive, and all. So you can check out this repo if in case you find any MCP server which is relevant to your end-to-end use cases. You can just use that particular package. All right. So the format is very simple. Let's suppose you have all these MCP servers. You want to pick one of them, right? Every single MCP server has the same example usage. So you start with a name. So the name here is Quadrant, which is a vector database. And if you have any other MCP server as well, you will have the relevant name. And now you have 3 parameters. So the first parameter is command. So command is basically how you want to execute that particular MCP. So it can be via UVX. UVX is, again, developed in Rust, but it is used in Python. Then you have Python. Then you have NPX. And then you have Docker. So these are different ways you can load that particular MCP server, and that you have to give in the command line instruction, which is command. And then you have arguments. So arguments is basically the repository where your MCP server is existing. And if in case you're using NPX, it will be the package name, right? And then env is optional. Let's suppose you're using any MCP server which has environment variables like API key, endpoint, or any other parameters, then you will be using env, which is your environment variables. But if you're using anything like local file system, let's suppose I want my MCP server to expose my entire system, which is my desktop. I want to give the flexibility of desktop, document. Then what will I do is, I'll give the permission. Hey, you have the permission of this particular folder. You can edit the files. You can delete the files. And you can make any modifications. So that is where it will come in arguments, which has no env, right? So env is optional. Only when any MCP server needs API keys or endpoint, during that time we'll be using envs. All right. So now that we have a bit of understanding of how MCP server works and how the interaction happens between MCP client and server, and also the basic format, let's talk about some of the MCP security concerns, right? Just now I said, I can give the entire flexibility to the MCP client. It can change, it can modify, or it can also edit the files that I have in my desktop. So when it comes to this particular permission, whatever permission I'm trying to do, MCP server can have different kind of prompt injection or tools injection technique, which it can modify, or it can also edit the files which is there in my system. And since you're giving permission, it can also apply any injection techniques, right? So some of the prompt injection techniques, it can be jailbreaking techniques. You have Dan. Have you heard of Dan? So there is some jailbreaking prompt techniques it called Dan. Dan is nothing but do anything now. And you have other prompt techniques like grandma prompting. So grandma prompting is like you give too much of nice information to the LLM so that it can't reject you, right? So this is grandma prompting. So these are some of the prompt injection techniques that one can use. And then you have tools injection. So let's talk about what tools injection is. I told you you have MCP server, right? Inside MCP server, there can be 10 tools, right? Now, in these 10 tools, I'm sending any user input. You have JSON RPC. Then it is trying to interact with the server, getting the response back. So during this time, you can have your own custom tools that you have built, which can be malwareous, right? So during this time, whatever tools, even out of 10 tools, one tool is not functioning well, it can not perform well in your entire application. Or it can also damage the permissions that you are creating within the particular MCP server. And then you also have something called a supply chain risk. So when we talk about supply chain risk, I showed you a screen where you had multiple MCP servers. And since most of the MCP servers are already developed, you'll be using the same one, right? So during this time, what will happen is, most of the time you will have to trust that particular MCP server if it is working well or not. So if you don't have the trust accuracy, but if you want to build the entire MCP server by your own, then you have to use a concept of AST. How many of you have heard of AST? Application security testing. OK, so basically, when it comes to supply chain risk, if you're building your own MCP server from scratch, you're building your own tools, you should follow the principles of AST, which is basically application security testing. Once you develop any tool, you have to run multiple testings of what can be the edge cases that you can encounter while using this application. Because at the end of the day, you're just giving the task, right? what tools integration is happening, what is the output coming from the tools, it's not up to you. It's up to the LLM, right? So during that time, you should have certain tests and the principles that you run when you're using the supply chain task. And then last comes logging. So logging is basically after every tool's integration, you should know what is the output and what are the different parameters it uses. So this is where I've written one detailed article on how you can. The screen is not changed. OK, so here we have a detailed article on how you can actually monitor and as well as trace the MCP servers. Let's suppose I ask a question. What was the tool picked? What was the response from the tool? Then what was the response from the LLM? So you want to track all of them so that when you're building any application, you will know, OK, where my system is going wrong. If it is functioning well, this is where you can track it and you can trace it. And you have a library called OPIC. So OPIC is mainly used for LLM observability. If you want to evaluate any LLMs, if you want to evaluate RAG, and if you monitor it, like what is the latency of it, what is the number of tokens you're utilizing. So all these things will be traced. You can also trace the cost for every single LLM calls that you do, right? So this is where OPIC is used, and you can also trace it for the MCP. All right. So here is a quick demo time. In this demo, what I'll try to do is I'll showcase how you can have your own MCP server, which is from the Quadrant Vector database, and then you're connecting with an agentic frameworks. So for this agentic framework, we'll be using Agno. So if you want to use any other frameworks like LangChain or Llama Index or also recently Google ADK, the format is pretty much the same. You define your MCP server first, and once you define your MCP server as a tool, so now, what is the MCP server here? It will act as a tool. When it comes to agentic frameworks, there are three major concepts you need to understand. The first is the tools, which will interact with the real-time information. Second is the decision making, how your model will be reasoning models, right? So you have different prompt techniques like React. React stands for reasoning and action, right? You will ask a prompt. So now what agent will do is it will think, then it will use an action, and then you have observation. Thought, action, observation, and the loop. So this is where you have the agent. So tools, decision making, and memory. So these are the three major components if you are building an agent. Now MCP, where does MCP sit in? It will sit at the tools part. Is it clear? And for your decision making capability, you have React prompting with large language model, and then you have memory. Memory can be a vector database, or it can be RAG application. So why RAG is used in memory? You can save all the previous conversation in memory. Whichever is the relevant to the new user query, you will just fetch it as a previous history, right? So is it clear, the three components? All right. As I said earlier as well, whether you want to use Agno or you want to use Google ADK or LangChain, the format is same. We will just focus on the syntax, and so that you can use it in any other applications. All right. So first step, we will start with MCP, which is our tool. If you want to install MCP, it is just one single line, pip install MCP. And now, if you see here, is the format same? If you see here, you have UVX. So what is UVX? So we had three parameters, right? One is command, one more is arguments, and third is env. So UVX is nothing but our command. And then you have MCP server quadrant. MCP server quadrant is nothing but arguments. So now, when you have command, when you have arguments, when you have env, this is mainly using stdio. If you are using streamable HTTP, you will have an endpoint URL, which will be a custom URL /SSE. So here, this is stdio. I'm defining a command, I'm defining arguments, and then I'm defining env. Since I'm using a vector database, I want to save all the data to the vector database cloud. So I need endpoint URL, and then I need API key. And then if you have worked with RAG, you might know what is collection name. Every single time I index my data inside a knowledge base, you create one collection name. If you want to bring your new data, you create a new index. So indexing happens only once, right? And to trace it, you use collection name. And then you have embedding model. Why embedding model? Because if you want to save data inside vector database, you need to convert that into embeddings. So this is where you have to define your embedding model. And next step is, once you initialize your tool, the next thing is you need to pass this tool to the agentic component. And this agent component, as I said, you will have your LLM. Here I'm using Gemini 2.5 Pro. Then you have tools. And after tools, you need to have instructions. So let me take one example. Let's suppose you're building a medical chatbot, And if I ask, hey, where is MCG located? Do you think it should answer? If you're building anything related to medical chatbot, and if you're asking general question, which is not related to medical, so should it answer as a chatbot? No, right? So you have to give certain boundaries. So this is where we have system prompt. How many of you know what is system prompt? Okay, so system prompt basically is you need to define 3 things. One is role play. What is the role that a LLM needs to adapt to? For example, you are an expert medical chatbot. Second, you need to define certain boundaries. So these boundaries are, you should only answer to the question that is related to medical. If not, you should not answer, right? So these are boundaries, these are instruction. Third, define certain motivation, but in a negative sentiment, right? So this motivation will be like, hey, you have a job. If you do this particular task, you'll get money. But if in case you're not performing this task, you'll be fired, right? I'll show one more example. Do you know Windsurf, the Codium CLI? I'll just show their system prompt. So this is how the system prompt looks like. This is from one of the CLI, not CLI, Cursor. So the competitor of Cursor is Windsurf. Here, if you notice, what are the 3 things I said you? The first thing is I told role play. So what is the role play here? You are an expert coder, right? What was the second thing? Instructions or boundaries. That boundaries is you will be given a coding task by the user, right? And it should do the coding task. And what was the third thing? Motivation, but in a negative sentiment. So what is the motivation here? The motivation is it will get 1 billion, but the negative sentiment is the mother's cancer treatment. Is this clear? How you write system prompt? All right. So all right, we are back. You have name. Name can be unique. And then you have your LLM, which is mainly used for decision making. And after that, you have instruction. Mainly, you have to define it as a system prompt. I've added, if you see, you need to define the persona, behavior, and the boundaries, which is nothing but instructions. And then finally, if you want to develop the UI, this is where we'll be using Streamlit. Streamlit has more than 80 different components which is available to you. You don't need to learn a new programming language. You just need to know English to build web apps. It's that easy. And if you want a button, you just have to use streamlit.button. If you need any forms, you just have to use streamlit.forms, right? The UI, it's pretty much clean. So this is how the UI looks like. If you see, if you need the entry box, you can just tell streamlit.text area. And then you will have the text area where you can add the user query. Then you have button to execute the query. Now if you see on the left-hand side, you have different parameters. So this parameters is nothing but tool. So basically here you have 2 tools. One is quadrant store and one more is quadrant find, right? So these are the 2 tools within the quadrant MCP server. Now, where is this used? What is the use case behind it? Let's suppose you're vibe coding, right? In vibe coding, what will happen is you generate a code. This code is very useful, and you want to reuse this code in your other applications as well. So now what you can do is you can tell to save this entire code in the vector database. So next time you want to reuse the same component, you can just fetch it from your vector database. One classic example is, let's suppose you are someone who is from research background of PyTorch, and you write same code for your convolution neural network. And next time, whenever you're using convolution neural network, you need to extract the same code. So what you can do is you can define the template, you can save that in the vector DB, and then next time, whenever you're reusing it, you can just fetch it from there. So this is one use case when you're using vector database related MCP servers. Is this clear? So here, if you see, the first step was write a poem on PyCon AU and save it in a vector DB. And what tool is it using? It's using quadrant store. Second, what I'm asking is, do you remember any poem on PyCon? Now, what is the tool it is using? Quadrant find. What it will do is it will fetch the results from the vector database. So I'll show what are the other parameters that it uses. So you have tool, you have success, and then you have duration, and then you have results. So this is what MCP server is sending. So what is MCP server sending? It's sending the results, and it's also sending the success message. And then you have different metrics, which will tell you what is the input tokens, what is the output tokens, what is the total tokens, and what was the duration to execute this query and save it in a vector DB. All these results, it's coming from LLM, right? And then you have the agent. Agent basically is the model that we have and the status of the response. So here, basically, I was using quadrant store. And now if you see here I'm using quadrant find, where I'm asking, do you know anything related to PyCon? It's using quadrant find. Here, the results are different. So whatever results you're seeing here is from MCP server. Whatever results you're seeing here, it's from the LLM, which is your agent. Is this clear? And if you want to see this code, since this was just the additional thing that I wanted to show you guys, you have the source code available. So you can just search for Lucifer TRJ, which is my GitHub repo, and then you have MCP client, which is MCP for dummies, which is my today's talk. And you will have the source code available. And second thing, as I said, you can also connect MCP server to Claude. This is where you need a JSON template, right? The JSON file, which I showed, command, arguments, and env. So that JSON file is also available in this particular GitHub repo. All right, and this is for the tip of the day before we can wind up. Most of you, I hope you are developers. And if you are developers, there are some of the MCP server tools or servers which is very useful to you. The first one is Context 7. All of us works in most of the updated repositories, let's suppose Fast API, LangChain. If you want to know what was the latest released MAST, and if you want to extract the information from the documentation, you can use Context 7. Then you have sequential thinking for step-by-step. And then you can use any memory or quadrant vector database related MCP server so that you can save it and fetch it whenever it's relevant. And if in case you want to learn more, you have a few playlist series. It's a selfless promotion. You can learn about agents, and you can also learn about MCP server in detail. And cool, this is it. You can also get access to my slides, which is you just have to search for bit.ly, and you have MCP for dummies. Whatever I discussed with the resources, it's available at this URL. And these are my socials. Cool. Thank you so much for listening, and this is it.